I'm Anil Kumar, and here is a very interesting question on composite functions. We are given if f of x equals to 1 minus x over 1 plus x, calculate f of f and write its domain. One reason of taking this question is that some of my students are not very comfortable working with fractions, and this involves now a lot of fractions, correct? So let's see how to find function of function in this particular case. So basically we want to find f of x, correct? So that means we need to find f of x is given to us as 1 minus x divided by 1 plus x, correct? Now f of all this means that what we can do is, let me do it here. In this function we have to replace x with that is what it is. Okay, so what we get here is 1 minus, so let me write it in different thing. So we get this x as 1 minus x over 1 plus x. Do you get the idea? Divided by 1 plus, we'll replace this x with all that, 1 minus x over 1 plus x. Now it is a question of simplifying this complicated fraction. To simplify, what should we do? We can take this denominator, make common denominator. So we get 1 plus x here. We have to multiply this by 1 plus x. So what we get here is 1 plus x minus, write this in brackets, 1 minus x, correct? Now all this is actually divided by 1 plus x. Think like this. It'll be easy, right? Same is the case with the denominator. I'll multiply 1 by 1 plus x. So I get 1 plus x, I'm again putting in square brackets, plus 1 minus x. And all this is divided by 1 plus x. You get the idea. If you write like this, it's very clear that they cancel out. Perfect, right? You could also write this division as multiplication. So it will flip and then you can cancel. Either way, it is good. Now, let's solve this. 1 minus 1 is 0. X minus of minus x will give us 2x. So we have 2x in the numerator. In the denominator, 1 plus 1 is 2. And x minus x is 0. So we get 2. That's simple, right? So that gives us 2 and 2 cancel. Just x. So what we get here is that f of f is equal to x. Now what does that suggest? Can you tell me that? So that is a question for you. So whenever we get function of a function, a composite function as x, it means what? It means this function is inverse of itself. So that's an excellent example. A function inverse of itself, right? So that is why you get x. Now let's get to the second part of this question, which is extremely important, and we need to find its domain. So what is a domain? Whenever you want to find the domain of the function, you should not look at the final result. Okay, what you have to look at? The starting point, correct? Domain. So the starting point of the function is f of x equals to 1 minus x over 1 plus x. So what are the restrictions here? X is not equals to minus 1. That is the restriction. So domain is all real numbers except minus 1 for the inside function. So that is one restriction. The other restriction should be that the output of this should not be minus 1, since that is the outer function. Now as you can see, here the output can never be minus 1. Do you see? Here horizontal asymptote is equals to y equals to minus 1. So the function will never have output of minus 1. Okay, and therefore in this particular case we have only one domain, right? So we can write domain of this function of function as x belongs to real numbers where x is not equal to minus 1. So in this particular case we have just one domain. It is important, however, to always check for range of the function should follow the domain of the outer function, right? So I think that helps and makes things very clear. So in this interesting example, we have a rational function whose inverse is what the function itself, and when we find composite function we get x as a result. And we also learn from this example that whenever you want to find the domain, do not go with x, because x is a straight line with no restrictions. You have to check with the function itself to write the domain, as we did. So we do have a restriction, x cannot be -1 for the given situation. I hope that helps. I am Anil Kumar. You can subscribe and learn a lot. Thank you and all the best.